people like Karl Popper for many decades were talking about the fact that scientific discovery is either always or in most notable cases not the result of a rational linear process, but the result of something which, for lack of a better term, we refer to as insight or intuition. And that the scientific method, which is so emphasized in academic circles, really focuses on how do we validate or falsify a scientific hypothesis once it's developed. But it doesn't really help us develop the new ideas that go to creating new paradigms. All of these issues are issues that Bill Byers has been addressing in his work. I hope some of you had an opportunity to see his new book, Deep Thinking, his previous book, Blind Spot. I had the great satisfaction in reading both of them and finding them so relevant to the work of the Academy that we've invited him here today to give us a special presentation.
It was a great introduction, Gary, so thank you very much, because I'm, as you know, vitally interested in the whole discussion following limits to rationality. As a mathematician, we think rationality is our thing, so to speak, and I will speak to that at some depth. This talk is really more about questions than about answers, but even more than questions, it's about developing a new perspective which can be applied to the problems that interest us. As you'll see in what follows, for me, developing a new perspective is the quintessential act of creativity. And my talk today is about the process of developing new perspectives. So it's not only about developing a new perspective as an objective theoretical framework, but it addresses the question of how does one develop a new perspective? What is involved in developing a new perspective? What is this that we mean by paradigm change? So it's clear that the talk is self-referential. And self-reference, not only as being a key element of mathematics, it seems to me a key element of human beings reflecting on the human condition. So it's clear that this kind of new perspective is what our society needs today. Without this new perspective, we will be stuck forever in the same old, what you might call, analytic paradigm, which today involves, I don't know, computers, big data, analytics, and artificial intelligence. Actually, I would claim this is not a new perspective. This is a very, very old perspective, at least 2,000 years old, and it's doomed to failure for reasons that I shall make clear, I hope. You know, today, computers are kind of mythological beasts for people who seem capable of doing anything. They seem to have an infinite capacity. And I claim that that view is wrong and almost silly for obvious reasons. Clearly, the computer focuses on one human capacity, which I could call the capacity for analytic thought. And it just multiplies that by a very, very large factor, making it faster and more powerful. And the idea behind it is that inevitably, quantity, in some magical way which is never made precise, morphs into quality. All of a sudden, you have, what do they call it, this omega point where computers become like fuzzy robots and our friends. Not to say that they have the capacity to do creative work. So I think it's important to realize, of course, that as we all do, that the human mind can be used in other ways than the analytic. And so basically, in order to make any progress on the questions which interest us, we have to break out of this paradigm which involves quantitative change and analytic processes. We have to be convinced, it's incredible that we need to be convinced that there are processes that we have access to which stand outside of the analytic. So when I wrote these books, one of the main things I was trying to ask myself is, can you develop a really simple way, a very simple and straightforward example to convince people that there's some obvious things that computers cannot do and will never be able to do? In order to make any progress, as I say, we have to get out of the analytic mind and its fixation on objectivity, rationality, and precision, and we must become familiar with things that don't live in that universe. Things like meaning, understanding, wonder, ambiguity, and contradiction. So the avenue that I've chosen to access these problems is the notion of conceptual systems. So I don't have to tell you what a conceptual system is. You all know it. The description of the course was all about conceptual systems. Let's just say for a moment that it's an integrated family of concepts that create a unified universe of meaning and experience. And of course, again, everyone knows, but just to restate it, we don't experience reality directly. We experience reality by means of the window of a conceptual system. Okay? So a conceptual system is important because it defines for us what is real. A conceptual system is not a model of reality, it is reality. That's to say, we don't access reality in the raw. A conceptual system, and we'll see this in some very simple examples in just a moment. A conceptual system you can think of as providing a context. Statements are meaningless without a context, but contexts are often suppressed or not referred to, or they're not made conscious. To show how important that is, of course, I would claim that a statement, for example, in mathematics, is neither true nor false unless you specify the context within which it's true or false. So specifying the context is everything, okay? And if that may seem like obvious and uncontroversial, but if you say that science is a conceptual system, and therefore a scientific law is not absolute, but merely true within a certain context, you see that we're already getting into sort of radical deep water. So I want to start, I want to say one more thing about conceptual systems before I go on, which is that a conceptual system is not only objective. A conceptual system is more than just, it has an objective dimension, certainly. Physics has an objective dimension, but what's not usually emphasized is that it also has a subjective dimension. Everyone understands a conceptual system differently. You bring your own culture, you bring your own language, you bring your own experience to your experience of this conceptual system. In mathematics, the most profound work is often done by people who understand a conceptual system in a completely unique way. That's often the key to great creativity. So a conceptual system is not objective, and therefore science and mathematics are not objective. So let's go on to a trivial example that I'm going to come back to, okay? Because when a mathematician talks to people, there's always this nervousness about using mathematics, which is too sophisticated. This time you can't accuse me of using fancy mathematics, because I'm going to start with the numbers 1, 2, 3, 4, etc. The counting numbers. The counting numbers are the first conceptual system that children learn when they go to school, right? They watch Sesame Street and they learn to count to 10 and then to 20, etc., etc. And then they determine regularities of the system. It's a really, really very deep and interesting system. And to begin with, one has to make the point that this system of counting numbers defines our notion of number. The counting numbers tell us what a number is. What is a number, you could ask? Is there an abstract definition for a number? Well, you know, in mathematics, number is not defined. Only certain kinds of numbers are defined. And counting numbers are the first example of a system which defines number. As I said, a conceptual system defines a certain aspect of reality. In this case, the aspect of reality that's being defined is number. Okay, so this system of counting numbers, of course, involves more than the numbers 1, 2, 3, 4. It involves also all the things that you can do with those numbers, like arithmetic. Add, subtract, multiply, and divide. It has more sophisticated ideas embedded in it, like the idea of order or linearity. If you want to get really fancy, you can define prime numbers, and then you can spend the rest of your life investigating the regularities of that system. But this system is enough for me to point to certain properties of conceptual systems in general. Just one example will lead us to the following general characteristics of conceptual systems. One, a conceptual system is essentially infinite. If you're a number theorist, you work within the field of the counting numbers. And as I say, you can spend your life proving theorems about the counting numbers. There's lots of conjectures about the counting numbers which are neither proved nor disproved at the present time. Number two, a conceptual system is stable. A conceptual system is a universe, a stable universe. You live often within that universe. Leaving a conceptual system is, on the other hand, scary because there's a certain security and stability for staying within a conceptual system. So there's a resistance to leaving. Three, reasoning with the system within a conceptual system is primarily, but not necessarily, systematic. Reasoning is systematic. That means it's logical, it's rule-based, it's computational. A good example is, of course, the algorithms for adding and multiplying, say, 2 or 3-digit numbers that we learned in school. So often you work within a system by developing computational devices or regularities which you prove by logical means. So I said, infinite, stable, and the reasoning is systematic. The fourth property of conceptual systems, which is relevant today, is that every conceptual system is fundamentally incomplete. Every conceptual system is incomplete. That means that you can state things within the system, you can state questions within the system that you cannot answer within the system. So the system provides you with a language in which you can use to frame questions, but in order to answer those questions, you have to go to a higher order system. So I maintain that every conceptual system is incomplete. That comes, okay. But I'm not interested in conceptual systems. I'm interested in how conceptual systems change. And that they do change, that they are stable, and yet they change is a fact of everyone's experience. You started off thinking a number was a counting number, and at some point in your academic career as a very young child, you jumped to the world of fractions. After that, you thought that a number was a fraction. Okay? Those are two distinct and logically separate worlds. So the question arises as to how conceptual systems change and what mechanisms are involved. I must add that that is a big question that developmental psychologists are interested in. They call changing conceptual systems bootstrapping, stealing a word from the philosophy of science and from theoretical physics. Of course, pulling yourself up by your own bootstraps is impossible, and a priori, changing conceptual systems seems to be impossible, and yet it happens. So I claim that there is a way of using the mind that is engaged in conceptual change. I think it's distinct from analytic thought, and I gave it a name because that's our tendency to give things names, and so that's what I call deep thinking. Whatever it is that's involved in changing conceptual systems, I call it deep thinking. I have lots of other names for it. If you want to be very poetic, you could call it the mind of revelation, because changing conceptual systems always comes with a kind of revelation. You could call it insight, or you could just call it creative thought. Deep thinking is the essential aspect of creative thought. It involves paradigm change. It's involved in reframing a situation. It's involved in child development and a certain kind of learning. But basically, when I'm talking about deep thinking, I'm talking about the creative process. So now we have two ways of using the mind. The ordinary logical analytic way, which is how we're going to use the mind in this seminar, and this other way that we're groping towards, which I call deep thinking, which is involved, which we all believe is involved in changing paradigms. And we all seem to feel that a paradigm change is what's required. So we're looking about how do we get to deep thinking. So now I want to discuss some characteristics of deep thinking. A, deep thinking, I mentioned that every conceptual system is incomplete. Well, deep thinking always arises out of the problematic. It doesn't arise out of a logical sequence of thought where A implies B implies C implies D, and at the end, A to Z is deep thinking. That's not how it works. It always arises out of something that's problematic. So in my trivial example, what's the problem? The problem is very simple. You can't take 3 minus 5, or you can't divide 5 by 3 and stay within the system of the counting numbers. You can divide 5 by 3. 3 goes into 5 one time, and it leaves a remainder of 2. So that is something that can happen within the counting numbers. But you can't say that 5/3 is a number and stay within the counting numbers. You have to leave the system for a new system. And that is a great moment in the history of thought. It is the birth of rationality. What was rationality? Why did the Greeks make such a big deal out of rationality? Okay? Because whenever you have this kind of insight, it is so powerful, you think that it describes everything. And the Greeks thought that the world was rational. That is to say, all relationships between entities in the natural world could be given by the ratio of whole numbers. Okay, so now we've all done this as children, so it doesn't seem like a big deal to us, but it is a very big deal. It is, in fact, a very big deal. And to understand why it's a big deal, you have to ask yourself in all seriousness, why is 2/3 a number? Well, you all know you could make a pie and cut 2 segments out of it, so it's 2/3 is a relationship between 2 and 3, but why is it a number? It's not at all obvious. It takes a creative act to see that 2/3 is a number. And this kind of change, this kind of conceptual change involves what's called reification. You take a process, this sort of comparison, and you make it into a number. Very often, computer processes are reified into concepts in this way. So that is one essential way that creativity shows itself. But the important thing, not only is that deep thinking is grounded in the problematic, as I said, but that 2 conceptual systems, which cover the same ground, like counting numbers and fractions, are incompatible with one another. Unless you see the incompatibility, you don't see what's going on, really. So to see that these two conceptual systems are incompatible, imagine you ask a child, how many numbers are there between 2 and 3? So one child will say, there are none. And that child is living in the conceptual system of the counting numbers. If the child says, no, there are lots, 2 1/2, 2 1/3, 2 1/4, that child is living in the conceptual system of the fractions. You notice that these two answers contradict one another. You can't say one is right and the other is wrong. They're both right, or they're both wrong. Depends on the conceptual system you're talking about. But on a deeper level, by the way, so it all sounds trivial when I'm talking about children, but if you've read, and I'm sure you all have, you read Thomas Kuhn, what did he discover? He said that paradigms are incompatible with one another. And he didn't use the word incompatible as I am, he used the word incommensurable, which is another word that comes from mathematics in the Greeks. He said that paradigms are incommensurable. That's why it's difficult to shift paradigms. So this is the fact of incompatibility is a very deep property of conceptual change. It's the reason that conceptual change seems impossible from a certain point of view. And if you want to know why that is, why this incompatibility, the deeper reason is that a conceptual system doesn't describe reality, but defines reality. So if you have two conceptual systems sitting around, you now are defining reality in two different ways. And how's that for cognitive dissonance? Reality is singular. Reality can have two definitions. The mind resists having two definitions for the same reality floating around. It follows from this conversation that deep thinking is sudden and radical. You don't reason your way to a new way of looking at the world. You have one way of looking at the world, and all of a sudden it occurs to you that you should, if you only thought about things in this completely different way, the problems of your original way of thinking would just dissolve. Deep thinking, as I say, comes from a certain very strong kind of incompatibility. It's in fact grounded in contradiction, as many people have pointed out. I have some quotes here, and I don't have a lot of time, but let me just mention the writer F. Scott Fitzgerald, who said, and I quote, "The test of a first-rate intelligence is the ability to hold two opposing ideas in mind at the same time and still retain the ability to function." Hold two ideas, two contradictory ideas in the mind at the same time, and but don't do the logical thing by saying, well, it's a contradiction, we have to reject A or B. You hold A and B simultaneously. And Albert Rothenberg, who was a professor of psychiatry at Harvard Medical School for many years and did a lot of work on creativity, coined the term Janusian thinking, which he defined as actively conceiving multiple opposites or antitheses simultaneously. Conceiving antitheses simultaneously, which comes down to exactly the same thing. Lots of people have said that, but it is not the general wisdom. So that tells us what deep thinking is as a process. But it works on various levels. Because remember that the conceptual system have a built-in incompatibility. Nevertheless, and now we get a little bit more subtle, conceptual systems are often hierarchical. By hierarchical, I mean that one system is contained inside the other. For example, the counting numbers are contained inside the fraction. Every counting number, let's say 7, is a fraction, 7 divided by 1. So it's simultaneously a counting number and a fraction. When you think of it as a counting number, you carry along all your intuition and your experience of the conceptual system of counting numbers. When you move to the fractions, you don't forget the things you used to know about counting numbers. They stay around. You have that whole system that still works for you. But when you think of it as a fraction, you can do some things that you couldn't do in the world of the counting numbers. For example, you can divide 7 by 2/3, and that works. But it doesn't work in the counting numbers. Okay. So conceptual systems in the same subject, like conceptual systems for number, tend to be hierarchical. Now, to live in a hierarchical system where you have an object with multiple meanings requires the systematic use of ambiguity. You have to think of a number simultaneously as both a counting number as a fraction. In order to live in the world of the fractions, to be fluent, let's say, in that language, you have to have this way of thinking where you have the freedom to think of things in one way or the other way, even though from another point of view, these two ways of thinking of things are contradictory. So let's compare for a second deep thinking and analytic thinking. Deep thinking is discontinuous, fundamentally discontinuous, sudden. Analytic thought is systematic or continuous, computational. I gave you various words. 2, deep thinking is fundamentally difficult or complex. Analytic thought, on the other hand, may be very complicated. You may have very, very long strings, as you have in computer programs or mathematical proofs. But I maintain it's relatively straightforward. A implies B, implies C, implies D. There are no gaps. And finally, a little metaphor. Ambiguity is to deep thinking. Ambiguity and contradiction are to deep thinking as logic is to analytic thinking. When you're talking about deep thinking, you're moving into a different domain. And if you try, as computers do, to access deep thinking through a program, you can see how that's clearly impossible. Now, I want to say, I said that conceptual systems are inherently hierarchical. And in mathematics, they don't stop with the fractions, obviously. The Greeks lived in another conceptual system, which was a geometric conceptual system, where a number was a length. And that's a perfectly good conceptual system. You can do arithmetic in that conceptual system fine. It contains all of the fractions. But of course, there were always this problematic element in the fractions, which was that the Greeks discovered Pythagoras' theorem. And Pythagoras' theorem told you that the square root of 2 is not a rational number. So now you have this perfectly nice geometric number, which doesn't exist in your arithmetic world of fractions. So your arithmetic world of fractions breaks down at that stage. And if you hear what happened to the Pythagoreans with the square root of 2, you see it wasn't very pleasant for them. And you can actually get a little feeling for that by the very words that they use. Why the word irrational with the connotation that irrational has? And as a matter of fact, in mathematics, there are all these very strange words. We talk about negative numbers, irrational numbers, complex numbers, imaginary numbers. Why such strange words? They all imply that these things are unreal in some way. Why is +2 positive and -2 negative? Why do they have these almost emotional connotations? It speaks to the difficulty of moving from one conceptual system to another conceptual system. It speaks to the difficulty, the inherent difficulty of the creative process. One of the reasons why this discussion, in my opinion, is relevant to us today has to do with technology. To my mind, every significant technological change is not important because you have a new gadget. It's important because it carries a new conceptual system. which I call technological conceptual systems, right? As my my compatriot Marshall McLuhan said, the medium is the message. Okay? So the medium is the gadget, the telephone or the cell phone or whatever, but the message is the conceptual system. That's why children find it easier to access new conceptual systems and new gadgets than we adults do, because for them, they are born into this conceptual system, whereas we have to change our conceptual system and eventually say, it's too much trouble. I'm not gonna get on Twitter. I'm not gonna, I've had enough conception of these gadgets. I'm resigning from technological change. Now, there's one final thing that I want to say of deep thinking, and it is essentially comes to the heart of what I want to say today, and it is paradoxical in itself, which is I want to claim that deep thinking is natural. In other words, I don't have to teach you deep thinking. Deep thinking comes with the territory. Deep thinking is how the mind works naturally. What's the problem? The problem is that we're blocked. Okay? So for most of us, we can't access it. We're stuck in the analytic. To access deep thinking, you have to break down your fixation on the conceptual system that you're living in. And how do you break it down? Okay. So there is a paradoxical element here, because I said deep thinking is fundamentally difficult on the one hand, and here I'm saying it's natural on the other. Okay? And if this lecture is to be in any way it's true to the subject we're discussing, namely creativity, I have to present you with a challenge, and the challenge is this paradox. How can something be difficult and natural at the same time? And I point out to you, just as a very simple example, whenever you've worked on a difficult problem, certainly I have, and you've been thinking about this problem day and night, and you can't make any headway, and at some point you say, it's impossible. At our current state of knowledge, there's nothing. We can't do anything. You just let it go, and you walk away, and one day you're walking across the street, and it just hits you that if you thought about it in this new way, in this other way, it's obvious. It's obvious what we have to do. It's just a wonderful, euphoric moment. We've all had these moments. Okay? So before the fact, it's impossible. After the fact, it's obvious. And there used to be as a joke as graduate students used to stay up all night trying to understand some very arcane piece of mathematics. And when one of your friends came to you the next morning and said, did you understand this thing? You said, oh, of course, it's obvious. A very misused word in mathematics. But obvious is what happens after the insight. It's the feeling that you have after you've obtained that, you've made that leap. It's things that were impossible to you before seem obvious afterwards. So I want to say about deep thinking, it's not the way the mind functions. Deep thinking to me is mind. Deep thinking is mind. Mind is not an object. We shouldn't be using a noun here. Deep thinking is a process. Let's use better words. If you want a word for mind, I suggest we substitute the word knowing. Knowing is a very ordinary, everyday word. It's not esoteric like mind that no one understands. Knowing. We know, and we know that we know. That's the result of any sort of creative thing. You know. And if you think about knowing, you think that we know many things. We know how to walk. We know how to do mathematics. We know how to write. We know how to talk. And it's the same knowing in every case. This knowing attaches itself to various things, okay? But I'm trying to unattach it. When you're talking about mind, you're going back a step, and you're going back, and what essentially you're doing is you're considering knowing independently of the objects of knowing. That is to say, you're understanding knowing in an intransitive, not a transitive sense. And if any of you have any experience in meditation, you know that in certain kinds of meditation, certain kind of meditation experience involves a direct access to unmediated knowing. Anyhow, I don't want to go there, but so if deep thinking is, as I claim, natural, then it shouldn't only be reserved for human beings. And indeed, animals, orangutans, chimpanzees, blue jays, solve problems, sometimes in a remarkable way. But not only that, processes of the natural world, the process of evolution, for example, has many of the characteristics, and I'm talking about both biological and physical evolution, has many of the characteristics that I listed for deep thinking, in particularly being difficult and sudden. So maybe there are processes in the natural world which kind of, in other words, deep thinking is actually built into the way things are. It's not something that we bring to it after we get computers or brains of a certain degree of complexity. Okay. So creativity, the essential step in creativity, and of course I don't have a lot of time and I'm being simplistic, involves this deep thinking. Of course it involves the analytic mind as well. I don't claim, you know, but the crucial step is the insight step. So basically, as we can see from the example of conceptual systems, creativity involves the breakdown and the recreation of unity. You have a conceptual system. That conceptual system is stable because it converts, it unifies a whole range of phenomena. And then it has internal contradictions as it breaks down, and in the creative step, you reconstitute it at a higher level. The news that the creative process is natural, of course, is very good news, because it means that we all, adults and children alike, carry this creative germ inside us. We don't have to teach people. They don't have to learn philosophy or physics in order to be creative. They are creative naturally. It also implies, of course, that there can be no algorithms or formulas for creativity. You know, I know a number of people who want to get rich because they want to create an algorithm, and then people will pay them to have their algorithms, and we'll have this algorithm for creativity, and we won't have to be creative anymore. We can just sit back and let the robots be creative for us. You know, there's that very strange dream that's floating around. But there can't be an algorithm for creativity. If there were an algorithm for creativity, then creativity would be a function of the left hemisphere and the analytic intelligence. But creativity is about escaping the left hemisphere and the analytic intelligence, so how could there be an algorithm? Similarly, it follows that computers are not creative, and that artificial intelligence may be artificial, but it's not intelligent. Deep thinking is intelligence. Playing around within a conceptual system is lots of fun, and you can do all kinds of interesting things, but fundamental intelligence is shown when we change paradigms completely. Like, okay, and that is hard to come by, but is what I'm interested in. And I quickly want to say that I don't want to get carried away with thinking that this is only about Einstein or geniuses or anything like that. This is about everyone. This is about children in school. Learning is fundamentally about paradigm change. People don't realize what a task they're giving a child when they ask them to learn the fractions. We don't appreciate it, and so we don't realize what we're asking of students and how hard it is. Because if we put an adult in the same situation where the paradigm that they were used to broke down and doesn't work, and we demanded something of them which they could not do within their present conceptual system, they would be angry. They would feel humiliated. So deep thinking is something that we actually demand of children, but we're afraid to demand of ourselves. This whole discussion shows why, when you talk about the mind, you have to be very careful, because mind is basically unknowable. It cannot be defined. It cannot be made precise, in my opinion. To know something is to grasp it in conscious thought with focused awareness and the analytic intelligence. It's what has been called flashlight awareness by developmental psychologists. Something we learned later in our lives, but we started our lives in another form of consciousness, what's been called lantern consciousness, which is kind of diffuse consciousness, which isn't focused, where we identify with everything that we see. Nowadays, we're so married to this adult kind of consciousness that we're trapped inside it. We cannot define mind. Mind is the primordial domain out of which ideas and concepts emerge through acts of creativity. Certain things you can define and certain things you can't define. It requires a certain humility to realize that there are things that you cannot define. In mathematics, it's obvious. You can't define number. You can't define randomness. There are lots of things. You can't define time. You can't define energy. You can't define beauty. Why try to define beauty? Don't waste your time. That doesn't mean that these things are meaningless. It means that they just do not live in the analytic universe. They are not subject to precision and logic. Number is meaningful, but it can't be defined. I don't think we make progress unless we see that this aspect of what can be captured in this kind of focused analytic intelligence and what cannot. You know, if I give you a 2-second review of the history of science, science starts off being deterministic. You have a deterministic conceptual system, which you think describes the world now, allows you to predict, 7 differential equations which describe everything, and including predicts the entire future and the entire past. And then we discover uncertainty. We discover quantum mechanics or statistical mechanics, or we discover the theory of chaos, or we discover Gödel, or we simply gamble. And we discover that there is uncertainty in the world, and that uncertainty is outside of our current conceptual system. So what do? And this is the crucial point. We define uncertainty. We create algorithms for uncertainty. And now you get to the financial crisis of 2008, because these people defined uncertainty using a certain stochastic differential equation, and they thought, therefore, that they could control risk. They could banish risk and uncertainty from the world. But risk and uncertainty cannot, if you follow me. All conceptual systems are incomplete. All they did was they pushed it to another level so that when it really did reassert itself, the whole bloody financial system collapsed. Then they just make the problems worse by this erroneous idea that we can eliminate this kind of uncertainty, or that conceptual systems grasp reality. So just to review, I'm saying mind is primordial. Mind is built in. I know it's a very unusual and controversial stance. don't try to deduce mind from the analytic thinking. Okay? I said that mind is knowing. Mind is unity. It is how unity comes to be understood, experienced in the world. And very importantly, mind is not a static object. Mind is dynamic. Mind is something coming into being. Mind is having an insight. The world is about change. We're not going to solve our problems by trying to create a system which makes everything static. Things are not static. Things are dynamic. So, this kind of knowing, this kind of mind, is what is real. Deep thinking is real. Knowledge, on the other hand, is a simulation. That's not to say it's not valuable, but all knowledge is limited. Okay? So that the main problem with artificial intelligence and this kind of way of thinking is it mistakes simulation for reality. It's so obvious. A simulation is not reality. It's a model of reality. Every once in a while, your simulation breaks down and you have to get a better simulation. It's a process without end. So let me end by saying the problems that I see in the world that you're also concerned about, and rightly so, exist because they're implicit in the dominant conceptual system. When the most educated people, and many that I've talked to, think of solutions to these major problems, they mostly think that they should apply the old tried and true methods. And those are the techniques of big data, of computer technology, of mathematical models. Those are the same point of view that has got us to where we are in the first place. These are not going to solve our problems. People imagine that if we just compute a little bit faster, a little bit more sophisticated way, all the problems will disappear. No, no, no. It's the conceptual system that created the problem. So we need a new conceptual system. You know, it's our birthright that we have access to mind, you could say, which is the supreme value. And we settle for an endless variety of technological gadgets. How sad that is. Thank you.
So many rich questions have come, and I know in some cases he might like to clarify some of the things he had to present in a very briefly with too little time to do them justice. So, Bill, I turn it back to you.
There's two I want to pick up, particularly because a number of people mentioned the continuous versus the non-continuous, for example. Okay? So I think the reality is that creativity is a combination of continuous and non-continuous processes. That's evidently true. You know, you know, we function in the world by using analytic thought and logic and these kind of things. It's not my attempt to denigrate these things. Okay? It's to say that not to get trapped at a certain level where it's how can I describe it to you? I was once doing a proof in a class, a graduate class in mathematics, and a student said to me, and you know, one of these long mathematical proofs which go through, you know, sort of A implies B implies C implies D, and when you get to Z, that's the conclusion. And the student said, I follow you, but I don't understand you. I follow the argument, but I don't understand it. And I think that's a useful distinction. Okay? It is possible to follow a strain of analytic and logical thinking without getting the main creative idea behind the argument. Every mathematical theorem stands on an idea. Every scientific experiment has an idea behind it. And it's sometimes, as teachers, we don't always, at least speaking for mathematics and not for any other discipline, we don't always elucidate the idea. We think the idea is carried implicitly by the argument, but it isn't. But it isn't. When you create an argument, often you have an idea in mind. And often professional papers, at least in my field, seem to go to perverse effort to hide the ideas. Okay, so it's a question of, okay, so there is a logical level, which is important for reasons of communication and consistency and a huge bunch of other things. But there is the level of ideas. Okay, it's sort of like when a student writes a term paper. You know, they list you 1,000 facts, and then you ask them, yes, but what's the thesis? What is there that connects all of these facts? What stands behind them? There has to be an idea. That idea is a creative act. Okay, and it's the same thing. Of course, science is logical. That is to say, you get the idea, and then you write a paper, and that paper incorporates your particular result with the whole body of science. And that is a logical process. But it doesn't mean that there are not non-logical factors which go into getting the idea in the first place. More than logical factors. Okay? So I think we have to cast our net beyond the kind of, and it seems to me this is a very important, because computers and computer programs are kind of paradigms of logical processes, okay? To denigrate the idea that you can capture creativity by an algorithm is a different story. Creating the algorithm may well be an act of creativity. So distinguish between those things. And I want to say something about the very interesting comments about the conscious versus the non-conscious. So it is true that a lot of our mental processes are non-conscious, okay? But since Freud, we conceive of the non-conscious as somehow inferior to the conscious in some way, and we don't realize that the importance of non-conscious aspects of thought, okay? Just because one is not conscious of it doesn't mean it doesn't exist. For example, we cut our finger and it bleeds, and then at some point the bleeding stops. The body stops the bleeding. How does it happen? I have no idea. Okay, it's not a conscious process. Or a child learns to walk. At the beginning you teach them how to walk, but very soon it becomes non-conscious, and we can think about mathematics as we're taking a walk. Okay, so yeah, absolutely, I agree with the idea that, you know, that it's kind of like there is this basin from which we draw our ideas. And then there's the question of whether, the question of mind and brain. I think when you look at instances of scientific creativity, there is a model, but there is a way, it's what I was trying to get at when I talked about conceptual systems. You're in the conceptual system, and then at some point, you know, it's the old story of Archimedes in the bathtub. He's working on a problem. He steps into the bathtub. He says, Eureka! Something comes from a totally different context, which he then reinterprets in terms of the problem he's trying to solve, right? How to know how much gold there is in the crown without actually melting it down, right? And it solves the problem. In other words, something comes from the outside. I've even read a very interesting book where they claim that the right side of our brain, in right-handed people, the left side of our brain involves the analytic. The right side of our brain involves something which is new. The left side of our brain recreates the world, okay? It's derivative, in a sense. You can see how things move from the left to the right side. You have an idea, and then you write it up, okay? You don't. So there's a difference. One has to understand what logical processes can do for you, those essential things that they can do, and what they cannot do. Okay, so it's not where you want to look for your new ideas. Okay, something must, and it makes a lot of sense in terms of conceptual systems. Something, when you have a brilliant idea, something comes to you from outside of the system. the system as you presently understand it. Okay? And sometimes the problem with systems, political systems, cultural systems, et cetera, is you take them to be everything. You have no idea of how you could get out. The problem to get out. And that's where this notion of contradiction is not to overdo this Hegelian aspect of thesis antithesis. Contradiction is a mechanism for getting out of your mental set. Okay? When you're out of your mental set, ambiguity as a problem is replaced by flexibility. Flexibility, after all, is just a way of reframing ambiguity. No, there are two ways of thinking about something, but it's not a problem anymore. Whereas before, the two ways of thinking about it seemed to contradict one another, so there was a terrible problem. So I'm afraid we don't have much time, so those are my comments. Thank you very much.